Hey everybody, Dr. A here, and in this video we're going to be exploring an example of applications of material properties. So let's go ahead and jump into it. In the given information, we're being asked to compute the deflection of point B in inches. We're being told that the moment of inertia is 300 inches to the fourth, and the modulus of elasticity, also known as Young's modulus, is 29,000 KSI. Remember, what is a KSI? That's kips per square inch, okay? So we're going to put that in our back pocket for now. So under solution, let's go ahead and figure out how we're going to approach this. The first thing I would do is imagine how this beam is going to deflect. Well, this is a cantilever beam, and so cantilever beams will deflect with a taper starting at A. It's going to be 0 deflection at A, and then it's going to kind of curve downward like that. Okay, curve downward like that. And this is the deflection we want, which also happens to be the maximum deflection. And if you think about it, that makes sense, right? If you restrain a beam rigidly, that's a fixed connection at A, and then you put a point load at the free end, this thing is going to be restrained at A, and as you get farther away from A, it's going to deflect more and more to a maximum value at the free end, okay? So we have a governing equation that was provided to us in our background video on this. This was delta B, or delta max, is equal to PL cubed over 3EI. Okay, do we have all of these values? Yeah, absolutely. We have them all. Let's substitute them in, but we got to be very careful. Watch what I do here. I'm going to say 2 kips. That's P. Now, what is L? Well, L is the total length of the beam. Now, notice that's 12 feet, okay? But we also need to be careful with our other units. Notice that E has units of kips per square inch. I has units of inches to the fourth, okay? So what we need to do is convert this 12 feet into inches, okay? That way we're going to have consistent units between L, E, and I, all right? So what is 12 feet in inches? Well, you just multiply 12 feet by 12 inches per foot, so you'll get that this is 144 inches. Okay, now knowing that my L is 144 inches, that's what I put into my equation, 144 inches, and then I'm going to cube that, and then we're going to say that's divided by 3 times. Now, E is 29,000 kips per square inch. That's what a KSI means. Remember, I told you to put that in your back pocket. A KSI is a kips per square inch. And then don't forget I, that's 300 inches to the fourth, okay? And so let's punch this in our calculators. We're going to be very careful here. We make sure we cube that 144. We multiply it by 2. We divide by 3. We divide by 29,000. And then we divide by 300, okay? One more time, just double check ourselves. 144 cubed times 2 kips divided by the coefficient 3 divided by 29,000 KSI divided by 300, and we get a number of 0.229 inches. Now, if you want to check your units, watch this, okay? The kips in the numerator, 2 kips, will cancel with the kips that are part of the units of E, okay? And then what else ends up canceling? Well, this inches squared that are part of the kips per square inch for E cancels with 2 of the inches when we had inches to the fourth. So that became inches squared. And then furthermore, that inches squared cancels with 2 of the inches up here, right? Because remember, this cubed goes in here. This becomes inches cubed. And so if you have inches squared canceling with 2 of these inches here, what are you left with? You're finally left with just inches, okay? So we kind of did a little unit analysis in our operation here. Make sure you pause the video and understand this. This is really, computationally, this is easy, but you have to make sure you have the unit management down and you're comfortable with that, okay? So that concludes this example. If this was helpful to you, please hit like and subscribe and be on the lookout for other content like this. Thanks for watching.